thought I'd post a video on how to use JMovie in order to do post-processing for KO. And in order to really understand how JMovie works, it's perhaps best to start with KO itself and look at how KO formats and outputs data to the ko.dat file. So this is the section of the code. This is around line 1430, and it's under this section here, write to file. And essentially, the write to file is right here. This is where KO outputs the data. And if you know anything about Fortran and formatted writes, this command here is the format for the write statement. So you can see I have two 8 character long integers followed by three 3 character long integers. So those 5 variables are these guys right here, the first 5. In count corresponds to the integer count for the iteration, and J corresponds to the position within the computational domain, the spatial position. IBCs are the boundary conditions. So the rest of these you can see are all going to be formatted as 26 long scientific notation with 18 characters after the decimal place. So here I'm writing time, the spatial location R, and then the spatial location R j plus 1, and then I've got a series of these BS variables which are written up here. So you can see what they are, BS 1 through 10. They correspond to the volume, the velocity, the pressure, the energy, the artificial viscosity. These are the deviatoric terms, and this is the temperature. So BS 1, 2, 3, 4, 5, there's a row thrown in here. So for example, if I wanted to know what this position here, if I wanted to plot the R position, if I counted over, this would represent the 1, 2, 3, 4, 5, 6, 7th variable that's written to the ko.dat file. All right, so with that in mind, when you go over to JMovie, JMovie is set up to plot either XY plots or movie plots. And either way, you need to tell it what 2 variables to plot. So when I say IX, that corresponds to the x-axis, and I set it equal to 7, that corresponds to the 7th variable within the ko.dat file, which I went and wrote them all here so I don't have to keep flipping back to that section of the code. But as I just counted off in the ko file, you know that the 7th variable written was R, the spatial location. If you went back and looked, the 20th variable written would be the XX stress, which is the deviatoric S1 minus pressure in megabar. So that's what this is doing for us right here. The next variable to kind of recognize is this I plot. So as I mentioned, you can plot either movies or you can plot XY plots. And the way that you change between the two is you set this variable I plot equal either to 1 or to 2. The next thing to know is this JJ. I've got JJ set to 1510. And what that corresponds to is if I go back into the KO movie file, the KO input file, and I go back and look at how many variables, how big the arrays are that I build within KO, you see that I built them to be 1510 big. And the reason I built it to be 1510 is if you go back and look at the input file that I'm using, it's about 15,000 or 1,500 nodes, 300 plus 1,200 there. And I throw in 10 because I need a few extra nodes on the ends for the boundary conditions. So that's why I set this to 1510. You don't really have to change this very often as long as you don't have a simulation that you're running that requires more nodes than 1510. All right, so in order to keep the accounting right within JMovie, it really needs to know how many variable writes you're doing for a particular time step. Sorry, how many spatial positions you're writing for a particular time step. That's what this 1510 corresponds to. All right, the last thing, variable that you would set as the end user is this tracers. Um, the tracers basically is if you're doing an XY plot and you want to know what is, say, the time varying velocity at a given point, this 1020 corresponds to uh, the node location or the 1020th J position in the spatial domain. All right, so this is set up to do a movie, and I'll just write this, and I'll go over to Octave and load in the ko.dat data. That takes a second to load that data in. And then I'll type JMovie. You can see that I'm getting a movie that corresponds to the variable 7, the spatial position, and 20, which is the x-axis stress. So if I wanted to look at something like velocity, I could just change this to 11, because I know here that the 11th variable written to the ko.dat movie, ko.dat file is velocity, and then I can close this and rerun JMovie. And now it's making a movie. Write that and save it. And there's the velocity movie. So I can run that again. Now you might want to see an XY plot. So it makes sense to do an XY plot maybe with something like time. Time is the 6th variable, and the we'll leave it at velocity. But let's set this node to be 300. The tracer here to be the 300th node. And the reason I'm doing that is because you can see here in my input file, there are 300 nodes that made up the flyer. So this is essentially the last flyer node, which would represent the interface between the flyer and the impactor. And let's run this movie. Oh dear, I forgot to change this variable to XY. So there's the plot. Now the x-axis is time, the y-axis is velocity. It's in centimeters per microsecond. So it rises up to 350 meters per second. It holds steady for a while, and then you can see when the wave passes over the release wave from the flyer, backside of the flyer passes over the interface, it drops the velocity down. So that's pretty much everything within um, JMovie. We'll scroll down just a little bit further. I've put some stuff in there like convert as a variable that you can use to convert units. Let's go back and look at this. This says don't change these variables. These are just some accounting keepers for the nodes counting. Once the code knows how many JJ, how many total nodes there are, it needs to kind of know where the boundary conditions are and things like that. This n is the length of the JMovie writes, and I set it to an arbitrarily large number, and that's why we get this error here, because it runs out of data, and Octave runs out of data, and it gives me this little error about, hey, I can't read any more data. And it's because I set this to an arbitrarily large number just to get all the data. It really doesn't do any harm. If I set this to a low number and I rerun this, you'll see it won't give me that error, but it won't plot all of the data either. So that's not very useful. So I go ahead and set it to a large number. You can see it's not plotting all of the data here, just to get it all. And that's pretty much it. Here's the two actual plots that I use for figure holds. You can see when I do an I plot equals to 1, which is a movie. This is the figure command, and we're looping through here. We're in a J loop, so that we're looping through all of the snapshots in time. And then here is the plot for the XY plot, and it's very similar. The last thing that's kind of neat here is that once you do an XY plot, it does pull the data out and put it in this file called data. So if you look, there's a file now that has two um, data plots in it that are 155 characters long, and that is the last XY figure plot that we've done. So it's just a convenient way to pull the data out. So there, I just plotted it over. You can see that's what's in this data record. So it's just a convenient way for you to be able to pull data out and write it to the command line, or write it to a file if you want, and then be able to use that data in some other application. All right, I hope that helps, and I'll post some other videos on KO and how to use it.